When we talk about the distribution of data or the shape of the data, there are a couple of terms that we use. We use the term symmetric data, and we also talk about skewed data or skewness. So we'll explore these by first looking at their definitions and then look at some visual representations. So when we talk about symmetric data, we're talking about data where all the measures of central tendency are about the same. Remember, our primary measures of central tendency are the mean, the median, and the mode. And it doesn't say they're exactly the same, but they're pretty close. They're about the same. Graphically, what we would see is that the left half of the graph would roughly be a mirror image of the right half of the graph. Now, data that doesn't fit that description is what we call skewed data. And it would extend then more to one side than the other. We would not have that nice mirror image. So let's look at a graph of symmetric data first. So here we have a graph where right here at the peak, this is where we would see our measures of central tendency, and this is in the case where they are all about the same. So we would say that the mode is equal to, and of course we mean about equal to, but we'll just use the equal sign, to the mean, about equal to the median. And so when we talk about that mirror image, we mean each side of the graph is approximately the same. So we have that mirror image. Now let me take a minute here to remind you that this normal curve is really just the same, it gives us the same information as a histogram. In what I mean by that is up here on the vertical scale is our frequency. So when we're at the peak, then we know that the values down here on our horizontal scale, these are the values that have the most frequency, right? Because they're at the highest bar. If we broke this up into bars, so the taller the height of the curve, that represents the higher frequency of the values that are here on the horizontal axis. Okay, let's look now and compare this symmetric data here with a skewed set of data. And so here, we'll just go ahead and get our a vertical axis, and we first look at the case where our data is negatively skewed. And in this case, there is a long left tail in the data. This is what we call negatively skewed. Another name for that is left skewed, because it has a long left tail. This side is longer and then it drops off quickly over here. So we can see here our measures of central tendency are not all equal. And in this case, the mean and median are to the left of the mode. So the mode would be here, and then maybe the median and the mean. Now, the order of the median and the mean, which one's first and second, can change, but they're always both to the left of the mode. And here's our, of course we have a horizontal axis running here with our different values on that, and this being our mean value, our median value of our data set, and what our mode was for our data set. Okay, so negatively skewed, a long left tail. Let me write that, long left tail if it's negatively skewed. Okay, let's look at the next case. Positively skewed. So I'll put my vertical axis here again. Positively skewed data has a peak early and a long right tail. Okay, so let's note that this is positively skewed. Or right skewed. And it has, let's see, get a different color, a long right tail. And in this case, the mode is over here to the left of the mean and the median. So here's the mode, and then we'd have the median and the mean in either order. The order of these two can change, but the mode would be on the left. So many distributions that we'll deal with are actually very much close to a symmetric data set. Not exact, but the mean, median, mode are approximately the same. So that's a lot of the data that we will deal with. When we do look at skewed data, it is more common to have positively skewed data than it is to have negatively skewed data. Because if you think about it, most of our data sets will have values that start at 0 and may go, to any number, but we just don't have any negative values. So therefore, there's a more common for us to have some extreme positive values out here than to have extreme negative values over here. So if our data is skewed, it's much more common that it be positively skewed. So this is more common than negatively skewed. But we will see most of our data will be that approximate symmetric data. So for an example of this would be something like income. It's much more common if you were getting the average income of, say, a county in Tennessee. You just want to find out what the average income is. Well, there's a really good chance that there are just a few people making really super high salaries that stretch this right tail out here to the right. And most of the salaries would be somewhere in here. So that would be more common than that you had some really one person with or a few people with very, very, very low salaries and everybody else pulling to the right, pulling the curve to the right. So that's why this would be more common. So we get an understanding now of symmetric data, left skewed data, where the mean and median are on the left of the mode, and we have a long left tail, right skewed data, where the mean and median are on the right of the mode, and we have a long right tail. And the right skewed, positively skewed, is more common in the skewed data than the left skewed.